All right, this is, what is this? Motion of a particle or movement along a polygonal path. Whatever. It's going to create a piecewise function. So for all of these, I'm going to have to find the lengths of these segments. So I guess I'll do that first. Find the lengths of the segments. Remember the distance formula is x2 minus x1, square root thereof, minus y2 minus y1, square root thereof, square root of that. So I'll do the distance of this part here. It's 2 minus 0 squared, which is 4. 2 squared is 4. Plus 3 minus 0 squared, which is 9, and then square root thereof. And that's square root of 13. I'm just calculating these. This one, I can see the distance is just 1. This one is going to be 4, 4. And this point is 3, 3. So it's 4 minus 3 is 1, squared is 1. Plus 4 minus 3 is 1, squared is 1. 1 plus 1 is 2, square root thereof, square root of 2. Okay, now I can answer these questions, and I'll get down to this piecewise function. And by the way, the piecewise function, the limits are going to be, or the domain of each part is just going to be where each segment starts, where each segment ends. So I'll get to that in a second, but let me do these questions. What value of s yields the coordinate 2, 3? Well, to get to 2, 3, that's point A, and the value of s, the distance, is square root of 13. How about y? 1 plus square root of 13. Oh, wait a minute. Oh yeah, no, I'm on the right one. Y of 1 plus square root of 13. Well, here's square root of 13. Here's plus 1. What's the y value at the end of that distance? The y value is 3. What's x of 2? What's x when the s distance is 2? Well, square root of 13 is like 3.6 something, so it's somewhere in here. So it's just going to be the final value of x at the end of that segment, which is 2, divided by the distance, which is square root of 13. And then this one, y of 4, here's square root of 13, that's 3.6. Then this is 1, so at the end of this, it's 4.6. So 4 is somewhere like right around there between A and B, and what's the y value there is 3. Okay, now I have to set up the piecewise functions, and if I can get these domains of each segment, then I've got my answer for the value of x and value of y, and I'll show you how that works. All right, so the first segment goes from 0, less than or equal to, and then that distance, square root of, less than or equal to s, and then the end part of it is, at the end of that, I've gone square root of 13, so less than square root of 13. And why this doesn't look, for some reason, it's not drawing on certain parts of the screen. I don't know what's going on here. Let me try to fix it. I don't know how to fix it. Okay, this is supposed to be less than or equal to. All right, that's better. All right, the next segment, I'm starting here. So I've gone a distance already of square root of 13, less than or equal to, oh, wait a minute. I want to draw that down more. I need to give room. Square root of 13, less than s. And then what distance gets me to the end of this segment? Well, to get to point B, it's square root of 13 plus 1. So less than square root of 13 plus 1. And then the final little segment goes from square root of 13 plus 1, square root of 13 plus 1, less than equal to s. And this last time it's less than equal because that's the end of it. Less than or equal to whatever that distance is, which is square root of 2. Okay, then I need to write the part for x of t, and I need to write it for y of t, y of s, x of s and y of s. Okay. Hold on, I want to try something here. Yeah, I don't know. I don't know why sometimes it's struggling to draw in certain areas of the screen. Anyway, it's going to be, as you can see in the formula, it's going to be the change in the x or the change in the y divided by the length times s minus s where it starts. So in other words, s minus this left part of the domain of that segment. plus x1, the lowest x value in that group, in that segment. So here the lowest x value, in the first part, the lowest x value is 0, so it's going to be plus 0. And then there's nothing before it, so it's minus 0, but it's s. And then how much does x change? X changes 2, divided by the length, which is square root of 13. And I still haven't given enough room. I'm telling you, it's always much more room than I think is needed. Okay, now I should have enough room. Okay, and then for the y, what is it? Well, y changes from 0 to 3, so there's a total change of 3 for y, divided by that square root of 13 times s, and it's really times s minus 0 and then plus 0, because it started at 0 and there's 0 distance before this part. Okay, how about for the next one? Well, this is going to be s minus square root of 13, s minus the start there, and then that's going to be multiplied by how much does x change? X changes by 1, divided by how much does, what's the distance, the total distance it travels? 1. And then plus, what's the starting point? What's the x value where it starts? The x value when it starts is 2. And then for the y, very similarly, it's going to be s minus that square root of 13, the left constraint, left part of the domain, times, oh, no it's not. What am I doing here? Look at this. In this segment, y is always 3. I don't have to worry about all that. Y is always 3. All right, now the final segment. Remember, the distance is square root of 2, the length. So this is going to be, how much does x change? X changes by 1. It goes from 3 to 4 in this last part. So x changes by 1. The length is square root of 2 times s minus square root of 13 minus the quantity of square root of 13 plus 1, which is minus square root of 13 minus 1, plus whatever x started at the beginning. X started at, I'll zoom in a little bit, at the beginning of the final segment, x started at 3. And for y changes by 1. It goes from 3 to 4, so this is also going to be 1 over square root of 2 times s minus square root of 13 minus 1. I'm subtracting the left part of the domain of that segment, so s minus quantity of square root of 13 plus 1. And then plus, where does y start here? Y starts at 3 as well. Did x also start at 3? Yep. So that gives me my x, my piecewise function. Remember, if you build the domains first, then that left part is what you subtract from s before multiplying it by how much does the x or y value change, divided by the length of the whole piece. That's it for that question.